Well, I'm pleased to introduce from Prague the engineer Katerina Knitskova, that will present the talking polyphenolic content in Hypericum and Ruscus species using HPLC and SMS, impact of extraction conditions on bioactive profiles. It's the last ring of the chain today to close the circle, and he's currently in the third year of doctoral program in biochemistry and inorganic chemistry, focusing her research and study and on the control plant adaptogens. Throughout the bachelor and master study, she specialized in the analysis of bioactive compounds and employing hyper HPLC, of course, coming with tandem mass spectrometry for the determination of matrices. During doctoral study, she has actively participated in several international scientific conferences where she presented her research finding in the group in Prague. So, Katerina, you are welcome. The stage is yours.
Thank you for a nice introduction. I don't know if you hear me, if I can just talk like this because there's less people now. So, as you heard, my presentation will be about polyphenolic content because throughout the day it sounded it's going to be some huge analysis of various parts, various compounds and various classes of compounds. But my study actually focused only on the polyphenolic content in Hypericum and Ruscus species, using high-performance liquid chromatography coupled with tandem mass spectrometry. I have chosen subtitle, Impact of Extraction Conditions on Bioactive Profiles. Maybe that in the end you will understand why I have chosen this subtitle. So in the first part, I'm just going to say a few words about Hypericum and Ruscus species, but we have heard today enough about it, I think. About their occurrence, biological activities, and what bioactive compounds they are consisted in the plants. Then I will talk about extraction of the samples, about different extraction procedures that has been used for this part of the project, and then about HPLC and SMS analysis itself of the obtained samples. And the biggest part will be results and discussion, how I interpreted the data, and some comparison between the plants. So, Hypericum andersonii is a herb that is common in Western Europe, North Africa, and Middle East. It has many different biological effects. It has antioxidant, diuretic, hepatoprotective, anti-hypertensive, anti-hemorrhoidal, antidepressant, skin protective, and so on. And for these biological effects are responsible bioactive substances from group of phenolic acids, flavonoids, triterpenoids, fluoroglucinol derivatives, and xanthones. I have obtained samples from this herb, and it was flower, leaf, fruit, and primary branch. The second part is Hypericum cellostifolium. It is one of the rarest species that is endemic here in Turkey and in Georgia. It has similar effect and it's morphologically very similar to Hypericum andersonii. And again, I have obtained same samples, both flower, leaf, fruit, and primary branch. The third herb was Ruscus Türleri. This herb is found in Mediterranean, Southern, and Western Europe. It has been known for the fact that it acts as vascular preventive, it is beneficial for the blood circulation, and it is consisted of many different bioactive substances, including, like the major ones are flavonoids and saponins. I have received samples and it was leaf and fruit. So now about the extraction, we actually today heard something about the extraction. So the first part of the samples I received was from Turkey, from Artvin. And for the extraction, ethanol was used. The extraction was conducted on a semi-automatic solvent extractor, as you can see. I hope it's the same as I put on the picture. And the temperature was 210 degrees Celsius. The duration of the extraction was 120 minutes, and the extracts were then dried and lyophilized. You can see again the samples I have received. Then the second half of the samples I received was from Italy, from Turin. And as the extraction solvent was demineralized water used. As a pre-treatment, there was ultrasound treatment for 10 minutes, and the extraction was performed on microwave-assisted multi-mode reactor. The temperature was 150 degrees Celsius with 5-minute heating ramp, and the duration was 30 minutes. Then the extracts were dried and lyophilized. So how I actually did the analysis. So first, when you want to determine bioactive compounds, you have to develop an HPLC-MS method. Our method was previously developed in our lab. So after you have developed method, you can take a plant sample and you can extract the bioactive compounds you want to quantify. Actually, I didn't do the extraction because I already received the extracts. I only diluted the extracts with mobile phase, and it was 40% methanol. And for the homogenization, we actually today heard that from other group from Romania that there was a problem with dilution. So I also had a little bit of problem with the dilution. So I used multiplate shaker for 60 minutes and then ultrasonic bath for 60 minutes. After that, I had prepared the samples that I analyzed using HPLC-MS, and then I did the data interpretation. So here are some more information about the method. You can see that, as I said, it's a method developed in our lab, and it's performed on instrument from Excellent Technologies. It's actually UHPLC coupled with triple quadruple, and basically it's not just one method, it's two methods. Those methods they have same chromatographic conditions, but the difference is between ionization mode. The one half of the substances were ionized in positive mode, and the second was ionized in negative mode. For the development of method, analytical standards were used, and based on the response, the method was developed, or the methods were developed. In the method, we actually are targeting more than 50 analytes, and for the quantification, we use dynamic multiple reaction monitoring, and we already applied this method for different plant matrices. And in the cross, you can see that if we do the extraction in our lab, we use 60% ethanol, and the extraction lasts for 1 hour at lab temperature. Here are the targeted compounds. You can see different classes of compounds, like phenolic acids, flavones, flavonols, flavonoids, isoflavonoids, and marines. So the results are here. Basically, what you get from the machine that you have chromatograms, then you integrate the peaks, and here are the numbers. But it's really hard to interpret a table like this, so I always tend to use some statistical method for the data interpretation. So what I used was factor analysis. I used factor analysis based on the hypothesis that the content of bioactive substances is actually dependent on the part of the plant or on the species. And those dependencies are resulting from the action of immeasurable factors. That's the theory behind the factor analysis. And it will help you to clarify covariance and correlation of original variables. And it will help you to reduce the set of variables. So this is the first plot. It's called score plot. I used software Statistica. Previously, I actually used the Excel stat, as we were talking about. But this one, it was really expensive, and we have Statistica free in our school. So this one software I really enjoyed. It's not really good plot, but still you can read some information from the plot. On the right side, you can see the samples. A mean Artvin and T mean Torino. So what we can see is one group It's Ruscus colchicus leaves, and the second group is Hypericum celesteifolia leaves. This is like one huge cluster of other not grouped samples. The next plot is loading plot. Here are all polyphenols that were quantified in the samples. It was actually 15 polyphenols throughout the samples. And if we do this superposition of the score plot and the loading plot, we can tell that in Ruscus colchicus leaves, those substances were abundant. It was caffeic acid, isoaromatine 3O-glucoside, rutin, ferulic acid. And that in Hypericum celesteifolia, naringenin 7O-glucoside, astragalin, naringenin, and luteolin 7O-glucoside and quercetin 3O-glucoside were quite abundant. But as I said, that is basically all what we can tell from these plots. I think that there wasn't enough data to provide nice graphs. So maybe if there were really more samples, the results will be then, the plot will be better. So yeah, there's a data shortage. So then, to compare the Hypericum androsamum and Hypericum celesteifolium, I just used those plots. Basically, in all of the samples, quercetin 3O-glucoside was the most abundant compound. And here you can see the plot in different parts of the plant of Hypericum androsamum and Hypericum celesteifolium. And you can tell that the concentration of quercetin 3O-glucoside was significantly higher in Hypericum celesteifolium. This is the rare plant than in the Hypericum androsamum. So it's those dark green plots. Then I omitted quercetin 3O-glucoside because if I would leave it in the graphs, you wouldn't be able to see anything else. So in the other graphs, there's only all of the other substances without the quercetin 3O-glucoside. And this is the flower and the comparison of Hypericum androsamum and Hypericum celesteifolium. And again, there's the same trend that the substances were more abundant in Hypericum celesteifolium. It's the luteolin 7O-glucoside, astragalin, naringenin 7O-glucoside. When it's just here, you can see it. And some of the substances wasn't quantified in those samples. The next part are leaves of Hypericum androsamum and Hypericum celesteifolium. Again, there's the same trend as it was before. That in the leaves of Hypericum celesteifolium, astragalin, luteolin 7O-glucoside, naringenin, and naringenin 7O-glucoside were significantly more abundant compared to Hypericum androsamum. In fruit, the trend was different. Now, in the fruit of Hypericum androsamum, it was actually richer in quantified bioactive compounds. And the last part is to compare primary branch. You see, back to the same trend as before, that in primary branch of Hypericum celesteifolium, it was actually richer in astragalin, luteolin 7O-glucoside, and in contrast to Hypericum androsamum, in Hypericum celesteifolium, rutin was quantified and quantified only. So, and to compare the extraction procedures, I have chosen 3 different compounds from different groups and compared the yield of extraction, and you can see there's ethanol and demineralized water. The ethanol is in green and demineralized water in blue. From the plots, you can see that more bioactive compounds were extracted using ethanol. And I was, during the research, I was wondering about the temperature. That it would be nice to compare because, as I mentioned, the temperatures for extraction were more than 150 degrees Celsius. Maybe it would be nice to compare if it's possible to use lower temperature because of the thermostability of the polyphenolic compounds. So I was, at the beginning, I was talking about Hypericum and Ruscus species. Then I have shown you the different types of extraction that was used during this experiment, then how I prepared the samples and the HPLC-MS-MS analysis itself. Then I show you how the statistical analysis can be really helpful for the data interpretation, but however still I ended using the Excel tables. And I would like to say that maybe in future it would be nice if there will be possibility to, for example, send us the plant material that we would be able to extract the plant material in our lab, or compare some other extraction procedures and see how the profile is differentiated. What different is actually in different types of extractions. So I would like to thank Martin Kuchář, my boss, Petra Cihlářová, and our laboratory, forensic laboratory of biologically active substances. And thank you all for your attention. And if you have any questions, I would be glad to answer them.
Thank you. Now your talk is open for discussion. If you have any question, you are really clear. You could excellently summarize all the data that including clusters for useful to better understand. Any
very clear presentation.
yes.
Only I wanna say about our temperature. To be sure, this because of is it okay?
Yeah, I was asking about the temperature, so I hope it's
Yes, it is. Who did
yeah.
I make the clarification. Thank you.
Yeah, maybe as I said, it will be nice in the future if you somehow change the temperature.
Sure.
Yeah.
We have
To explore it more.
We have several plants and some interesting machine for your lab.
Yeah. We are looking forward.
Well, of course, then we can create the connection between the composition and activity. That is the next step to, based on the knowledge some are quite common compound that they are expected, some other a bit less, but well, of course interesting to have this general view. Compliment to you and all the group for the excellent work in Prague. So, if it's not the case, we thank you so much once more. The second. Yes, yeah, the second. Where are the second?
Next one.
Next, Victoria. I could introduce Victoria in Italian. She just calls Italian. Yeah, multi-language. So Victoria is a principal researcher. Sorry. So Professor Dr. Victoria Lipson is working at the Department of Organic and Bioorganic Chemistry at the Institute for Single Crystal, mentioned before in Ukraine, head of the Medicinal Chemistry Department of Institute of Endocrine Pathology Problems, and professor of Chemistry School in Kharkiv National University. So she graduated from Kharkiv State University in 1984 with honor, obtained a PhD in 1992, and a doctor in science in 2008. Her field of scientific interests are synthesis and properties of nitrogen-containing heterocycles, Modification of natural compound for the purposes of medicinal chemistry and material science serve for compound with antimicrobial, antidiabetic, antioxidant, anti-inflammatory, and cardiovascular properties, drug design, supramolecular chemistry, so a wide domain of interest. So Victoria, the stage is yours.
Thank you, Giancarlo, for the presentation. Dear colleagues, I would like to switch your attention on the other class of natural compounds, also natural metabolites, which we can find in Ruscus and Hypericus, but unfortunately with low concentration. And why these compounds are very interesting for us and what opportunities they exhibited for organic chemistry and synthetical, organic synthetical. This is the example of plants which contains. Thank you. This is example of the plants which contains these metabolites. Three treated in with from urban series, and the main concentration of these metabolites are in the bark of commercially available trees. The main component of the birch bark is bidulin, which contain hydroxy group this and hydroxy group in this position, and the main component of the bidulinic acid, which contain carboxy group in 28 position of this system, and hydroxy group in third position. The main source of this bidulinic acid is the bark of platanus, 3% of dry material. But it is very low concentration, and there are many synthetic routes to obtain this acid, because it is very interesting for pharmaceutical purposes, and the most biologically active compounds are prepared on the basis of this acid. Why these compounds are so interesting for synthetic chemistries and pharmacologists? Because they showed the nano size molecular platform, enantiomeric purities of availability and renewability of natural raw materials, and functional groups which easily modified for different purposes, and not only second, third position, 28th, and this is a propanol fragment, but also cycle R can be modified by opening this cycle. It is possible and widely used in organic synthesis. The main source of this bidulinic acid, except bark of platanus, is the leaves of rosemary. This is main components of Urban series. This content of bidulin is from this paper, but we obtained this compound with high yield from bark of betula. It depends on the age of the tree, and the place in which it grows. Betulinic acid can be obtained by oxidation of betulin, or now is betulin is extracted from the this bark by different extract methods: steaming, sudslet, ultrasound, and microwave assisted extraction, and other possible methods, which was with great interest I today hear this lecture of Professor Korot. And we used in our synthesis betulinic acid and betulin, and the main interest in this compound are due to different type of pharmacological activity. First of all, the anti-tumor activity of flavonoids. This type of activity connected with at first it was determined as an inhibitor of melanoma cells. I think more than 25 years ago. But now the most of compounds in this series are hybrid compounds with different fragments of well-known synthetic active fragments of active pharmaceutical ingredients, such as cisplatin or artesinic acid. But some of them enter with different heterocyclic fragments, which can be unrelated to this molecular urban molecule platform or connected with the linker. It depends on purposes for use of these compounds. And if you can see, this compound is active against lung cancer cells, breast cancer cells, and unfortunately it inferior to the activity of the referent compound cisplatin, referent drug cisplatin. Interesting that this fragment of artesinic acid, it is a first line drug for treatment of malaria today. And with the connected with the Lupin platform, it shows activity against the glioma cells, but in micromolar concentration. But in nanomolar concentration, this compound exhibited high antimalarial activity. Anti-inflammatory activity of flavonoids in this series of secondary amides of cyclic amides of betulinic acid, the highest activities shows this morpholin derivative. Its activity close to the well-known and widely used anti-inflammatory glucocorticoid dexamethasone. And also these compounds possess antiparasitic activity, anti-leishmaniose activity, and their anti-inflammatory activity is connected with anti-leishmanial activity, because leishmaniose leads to the dangerous complication is cardiomyopathy, and this anti-inflammatory properties is very useful for treatment this so-called Chaga disease. Antiviral viral activity of flavonoids is started first compound of this type of activity was Biri by Matt first anti-maturicate inhibitor for human immunodeficit disease. And unfortunately, this compound, unfortunately, the protein, gut protein, possess different forms for different patients, and this compound was withdrawn from, rejected from clinical trials because low effectivity for some types of immunodeficit disease. And this compound modified azidotimidine with triterpenoid platform shows nanomolar activity, in nanomolar diapason. The activity and low toxicity, lower than the azidotimidine. Antibacterial, antifungal, and antiparasitic properties of flavonoids. Bacterial activity against Klebsiella and Escherichia coli shows these triazole compounds with fragment of hydrocyclic ribosylate, the mimic ribosic fragment, this tetrahydroforam fragment is mimic the ribosyl residual in the molecules. And this compound exhibited activity for the isoniazid and rifampicin and aflatoxin resistant strains of Mycobacterium tuberculosis, and some of these derivatives shows activity against antimalarial activity, and this is previously discussed compound with artesinic acid fragment is compound with nanomolar diapason of concentration, also active against malaria. Compound anti-leishmania's activity shows this heterocyclic pyrazine derivative, and anti-trypanosoma activity also. These representatives of compounds, and compounds from Lupin series with potential agents for treatment metabolic disorders is shown in this slide. These compounds are agonists of G-protein coupled receptors. They decrease the uptake of fat acid and fat, and be useful for treatment diabetes mellitus type 2, insulin independent diabetes mellitus, and decrease the obesity. We used in our investigation such lupinoid derivatives as allopitulin, which obtained by Marvin Wagner rearrangement of betulin, betulinic aldehyde, which obtained by oxidation with pyridinium chlorchromate, and betulonic acid, also obtained by oxidation of betulin. We synthesize the metatrexate belotonic acid hybrids and evaluate the effect on artificial dipylmatyl phosphatidylcholine membranes and Purple cells membranes. We obtained both isomers, both isomers of these Methotrexate. Methotrexate is anti-folic acid compound with anti-folic acid properties, which widely used in oncological practice, and not only in oncological, for therapy, autoimmune diseases such as rheumatoid arthritis or psoriasis, and long-term use of these compounds leads to resistance of this drug. And that is why this is the substrate for some transport systems, such as P-glycoprotein, which active expressed in intestine. And one of the possible way to prevent this is to obtain hybrid compounds, one part of which is not the substrate for this glycoprotein. And we obtained this isomers, and you can see this different yield, this main and this the minor isomer, and investigate their permeability across capote cells only, and unfortunately the permeability of this component, this hybrid compounds was very low, and it is near close to the adenole mediana. And it is interesting that the permeability of isomer 2 is more lower than the first compound. And we think that this is due to the high lipophility of these compounds, and they penetrate into membrane and distributed in this membrane, and it is that is why they exhibited low penetrating activity. We also synthesized some conjugates with peptide mimetics for 3 steps. First step is the Auger reaction with the obtained acid compound. Second step is the propargylic acid of the butyronic acid, and combine them by click reaction with triazolinker. We also obtained the same by the same the Spirox indoles modified butyronic acid, but modified this carboxylic group, and linked them by the triazolinker, also by click reaction. And examined antibacterial properties of this compound. And these compounds were not very active, low activity, exhibited low activity, but high activity against Pseudomonas aeruginosa and Staphylococcus aureus shows one representative of this series. We continue this experiment with Spirox indole compounds, and I hope we find more active compounds. This 3-terpenoid molecular platform is interesting not only for medicinal purposes, but for material science. And we synthesize some dopants for cholesteric liquid crystal composition, which used in bistable cholesteric liquid crystal displays. These displays characterize low energy consumption, does not require constant supply of voltage, does not treat polarizers, absence of energy-intensive lighting, and other features of this system, liquid crystal. And you may be used in the preparing color electronic paper, small devices, color electronic laser, and other devices. We synthesize the elegant derivatives of alabutulin and converted them into spira cyclopropan and spira oxyram compounds. And these compounds showed high twisting power, and the highest twisting power characterized for compounds with long chromosogenic fragment, with when in this position was a real fragment. And this compounds for liquid crystal composition, which contains pyrazole fragment, are the most active as dopants for liquid crystal composition. And this slide compare the commercial available compounds widely used for these purposes and our results, and some of them are nearly the best commercial examples. We established that the shape of molecule influence on the twisting power, ability to induce cholesteric supramolecular structure, and the shape of the highest twisting power shows the compound with which shape is near to the propeller form. And the highest dopant shows in this slide, it exhibits three colors in commercially available nematics, which used in such composition, and this compositions were stable during a long time, and exposure to sunlight, and it is a very good result from this. We also synthesize derivatives of betulin, triterpenoids based on betulin and epiandrosterone, and as components of smart gels. The spacer with different spacers, such as hydroquinone, rhizocin, and catechol. And the highest ability to form gels showed compounds from with catechol spacer and in for alabutulin compounds in toluene and for dihydroepiandrosterone in cephalohexanol. This is the scanning and electron microscopy images of dihydrogen testosterone-based serogels. And we attempt to estimate the ability of these compounds to form gel structure by simulation of quantum chemical calculation or molecular dynamics. And we concluded that gelling ability of synthesized compounds is primarily driven by the energy of intermolecular tail substituent interaction, and the less significant feature is the molecular unfolding in solvent, favoring the gelatin substances becoming soluble. And this is possible extraction by these gels. This is different dyes from water. And comparison with the traditional extraction by cyclohexanol or by other organic solvents, and this is you obtain the results of the extraction. And I'm very glad to be in this event. I thank the grant of Erasmus and all of you for your attention, for your hospitality, and the possibility to connect with you. And it is very important for us. And thank you very much. And this is our city now in Oturum.
For this wide overview and also the number of compounds that you present and the test and the activity and the chemical properties also in gel and other. So the talk is open for question, discussion.
Yeah, thank you, very nice lecture. I have a question about the properties of these gelating compounds. What about solubility in various solvents? Because I can expect that they are not so soluble even in organic solvents, yeah? Or they are.
These compounds are soluble only in organic solvents, such as chloroform,
Okay.
and other halogenated hydrocarbons. Toluene, cyclohexanol, these compounds don't solve in water,
Okay.
and this is the advantage for extraction is simply withdrawing the when you
Okay.
extract by other organic solvent, you must use some devices.
Okay.
And this is without devices.
Okay. And what about thermal stability? Because usually gels are in principle chemical homogeneous by heating.
42 degrees centigrade.
Okay. Thank you.
Typical property. We use in the time we did some study, gelification and so temperature or ultrasonics that can behave exactly in the opposite way.
Yeah,
This
yeah.
is very interesting.
Yeah.
Not for be generalized, but many compounds for thermal sensitive and also sensitive to sonication. Well, any other comments?
The pharmacological problems with these compounds is their low solubility in water. And that is why the betulinic or betulinic acid is more popular, but it does not resolve this problem. Any specialist does not resolve this problem with its low water solubility. But for some, yes, but for some purposes, it is not very important because we have different pharmaceutical forms for different gels, other pharmaceutical forms, type of drugs for not for systemic use. It is okay.
Well, let's move to the last speaker. Last speaker. Thank you for paying attention until this time because of it is very full scientific part, and we will see.
Alexandra Ionescu. So she's a student in chemistry at the Unarea University in Galați, Faculty of Science and Environment, and medical student at the Faculty of Medicine and Pharmacy. So graduated in pharmacy in 2020 and took her master's degree in chemistry in 2022 at the same university. She was also pharmacy, working as a pharmacy in the Cardiac Emergency Hospital, specialized in medical pharmaceutical laboratory analysis. So in the considering the activity in plant extraction, biochemical tests like antimicrobial activity, anticoagulant properties, anti-inflammatory effect, anti-cancer, obtaining nanoparticles with different natural compounds, and alternative green chemistry method using ultrasonics, microwaves, and biocatalysts. She is currently working in the study of biological properties of natural compounds with potential bioactivity as anti-inflammatory, antimicrobial, and enzyme inhibition, cholinesterase, amylase, and glucosidase. So, Alexandra, you're welcome. It's your turn.
Thank you. Thank you for the presentation. First of all, I want to thank you to Professor Mustafa that he invited us here, the entire team of Romanian team. And we think that this project is very important for all of us because maybe with this amazing research in the future we can change the world. And this presentation have an introduction about the different plants and the synergistic combination, the aim and the objectives, materials and methods, result and discussion, and the final conclusion and acknowledgement. The principal aim of the study was to explore the synergistic effects of plant extract combination between Sideritis isopicolia and Hypericum and Ruscus Serum. From these two plants we use flowers and leaves. And why we choose these two plants? Because of the chemical composition. And for the biological activity. Today we saw that Hypericum and Ruscus have a good biological activity and good chemical composition, but the Sideritis isopicolia is a plant from my thesis, and last year I made some tests about the chemical composition and about the biological activity, like antioxidant activity, antimicrobial activity, enzyme inhibitors, and we think that this plant have a potential for the future. A little bit about Sideritis. This plant have Familiariaceae family and have like 150 species. But one of them Sideritis isopifolia is special because if you will search on the internet, Sideritis species looks like almost the same. But this one, if you saw here, it's different. Different on the form of the plant and different on the smell of the plant. The articles about this plant is few, it's just few articles. But what we know is that the Sideritis, the name is from Sideros, that means island. And it's very important to ancient people that they heal with this plant the wounds that they made with the island weapons. And at the same time, they call it mountain tea because this plant on the highest areas. On the point of view of chemical composition, in this plant we have terpenes, flavonoids, essential oils, coumarins, toluene group and toluene groups. One of the important compounds in this plant is cholecalciferol. That means it's an empowerment compound, and it's in few articles we saw that it's used on the glioblastoma, that is brain cancer. And another activity that we saw, it was anti-inflammatory activity, antioxidant, anticholinergic activity, and antimicrobial activity. About Sideritis, the principal aim was to obtaining the extract with different solvents and then to see if these extracts have antimicrobial activity, if they have polyphenols and flavonoids, anthocyanins, and antioxidant activity. For materials and methods, we obtain the extract with different solvents, different bipolarity. And we use ultrasound extraction, then we wait to evaporate, and that extraction we will use in the next test. The result that we do was polyphenols and flavonoids, amount of polyphenols and flavonoids, and we saw that these species have, or this is different. We have methanolic extract, that one is fractionate, and this one is total extraction. And we saw that we have different composition. And in the point of view of DPH activity, we saw that these two extracts have a good activity, like 95% of inhibition. About biological activity, we tested on 3 different microorganisms. 2 of them was bacteria, Staphylococcus aureus and Escherichia coli, and the last one was Cryptococcus neoformans that was involved in different type of meningitis. And we saw that this plant have with 2 types of extraction, hexane one, and this is alcoholic one, have activity on this microorganism. Okay. The synergistic effect was, first of all, made with antioxidant activity with DPPH, DPPH method, and we have here 4 extracts. 2 is from Sideritis and 2 was from Hypericum, flowers and leaves. And we made 2:12 ratio that we tested with DPPH method, and then we obtain the ratio is here. We start with 75%, and then we complete it with 25%, 50-50, and then we change, and we do it for all of the extracts. And we saw that the best DPPH activity was at 11 ratio. That means the Sideritis isopifolia flowers combined with the Hypericum and Ruscus leaves in percent 50-50%. In the conclusions, the portfolio and the Hypericum and Ruscus show potential for future research in the pharmaceutical and medical fields. In the future, we want to combine different plants from Romania with this plant Hypericum and Ruscus to see if they have different synergistic potential. The antioxidant activity showed us that the different combination can have promising results depending on the concentration, and the convenient use of plant extract could improve the effectiveness and pharmacological action by obtaining synergies, acting on multiple targets simultaneously, reducing the doses of individual components and minimize the side effects. Further studies to elucidate the mechanism of action are needed in the future studies. The acknowledgement, we thank you for the entire project and to our university. The program and teşekkür ederim.
Excellent. Yeah. Comments or curiosity, question from the audience? You are closing with your examination, interesting data and comparing with the two plants or the pH. So it was very clear. So it's not the case, we are here still the next day. Now we have to put all together all this big amount of data to explore in terms of publication for the project itself. So I think I can invite Mustafa to close the day, and then I thank you all for all the activity, the rich activity that you provide again for the